Let's go through some DP-203 practice questions. Before doing so, thank you very much to my first 2 subscribers, Shaping Pixel and K. Bharath Kumar. Thanks guys, this one's for you. Question 1. You have a table in Azure Synapse Analytics dedicated SQL pool. The table was created by using the following transact SQL statement. And you can see the statement on the screen. You need to alter the table to meet the following requirements. Ensure that users can identify the current manager of employees, support creating an employee reporting hierarchy for your entire company, provide fast lookup of the manager's attributes such as name and job title. Which column should you add to the table? Well, the question is so long I almost forget the start of the question. So looking at the transact SQL statement here, we see that we're creating a dimension table for employee data. In order to meet the requirements, our basic idea is we can create some sort of key, and using the key we can join other dimension table as necessary to meet the requirements. So the important thing to consider is business key versus surrogate keys. So going over them quickly, business keys are something that could change unexpectedly, and it might have duplicates as well. Whereas surrogate keys are unique numbers assigned to each row. We use the surrogate key for the dimension tables. So looking at the options here, how do we tell apart surrogate keys from business keys? Well, surrogate keys conventionally have the word key at the end, whereas business keys has the word ID at the end. So looking at our options here, the first 2 options are business keys, and the third option is the surrogate key that we should add to the table. Question 2. You have an Azure Synapse workspace named My Workspace that contains an Apache Spark database named MyTestDB. You run a command in an Azure Synapse Analytics Spark pool in My Workspace to create a Parquet table containing the following data. So the data shows the employee name, employee ID, employee start date. You then execute the following query from a serverless SQL pool in My Workspace. What will be returned by the query? And the query shows that we select this table, and we select employee ID from this table, and with a where clause on the column named name. So quite a straightforward question here, and I think I've almost answered it just reading the question. Just looking at the query statement there, the where clause is acting on the column named name, but we can see from the table that there's no column named name there, so there will be an error. Another long question here, question 3. You have a table named SalesFact in an enterprise data warehouse in Azure Synapse Analytics. SalesFact contains sales data from the past 36 months and has the following characteristics. It's partitioned by month, contains 1 billion rows, has clustered column store indexes. At the beginning of each month, you need to remove data from SalesFact that is older than 36 months as quickly as possible. Which 3 actions should you perform in sequence in a stored procedure? So the SQL data warehouse supports partition deletion, merging, and switching. And looking at the options here, there are no options for deleting. So what we will be interested in is the partition switching functionality here. So as the question asks, it will be 3 steps. The first step is to create an empty table named SalesFact work that has the same schema as SalesFact. So we're basically we set up a table so that we can load the data in there. So what we do next is switch partition containing the stale data from SalesFact to SalesFact work. So we have an empty table all the things that we don't want, we just chuck it in there. So the after the second step, current situation is sales fact has our useful data. Sales fact work has data that we're not interested in. And third step, simply drop the sales fact work table. Question 4. You have files and folders in Azure Data Lake Storage Gen 2 for an Azure Synapse workspace as shown in the following exhibit. You create an external table named xtable that has location top folder. When you query xtable by using an Azure Synapse Analytics serverless SQL pool, which files are returned? And it's showing the file structure here. So it's very important to point out that the question is dealing with the serverless SQL pool, because the answer will be different if you're considering the dedicated SQL pool. So for serverless SQL pool, the files in the very folder that we are looking at, in which case in here is top folder, only those files are returned. For this question, the correct answer here is B, file 1 CSV and file 4 CSV only. If the question was to exactly the same but asking about the dedicated SQL pool, then the answer would be C, all the files would be returned. So for the serverless SQL pool, well, if we wanted to return all the files, what we can do is we can add backslash and double asterisk at the end of it. They will return all the CSV files. Question 5. You're planning the deployment of Azure Data Lake Storage Gen 2. You have the following 2 reports that will access the data lake. Report 1 reads 3 columns from a file that contains 50 columns. Report 2 queries a single record based on a timestamp. You need to recommend which format to store data in the data lake to support the reports. The solution must minimize read times. What should you recommend for each report? For this question, let's go through all the options first here. So we're given Avro, CSV, Parquet, and TSV. So we'll give one-liner descriptions for each of these. So Avro stores data in a row-based format, and CSV is like a human-readable format, like JSON and XML, but it's not optimized for storing and processing structured data. Parquet is kind of like a counterpart to Avro. It stores data in a column-based format. Lastly, TSV is a time series data structure. For report 1, we're interested in looking at columnar-based data, so we'll be considering Parquet. And for report 2, we'll be looking at a single line or a single row. So in this case, the optimal data format we'll be considering is the row-based format, which is Avro. Avro on top of the Avro is also compatible with timestamp data. Question 6. You're designing the folder structure for an Azure Data Lake Storage Gen 2 container. Users will query data by using a variety of services including Azure Databricks and Azure Synapse Analytics serverless SQL pools. The data will be secured by subject area. Most queries will include data from the current year or current month. Which folder structure should you recommend to support fast queries and simplified folder security? A good directory structure has parent-level directories for things such as region and subject area, followed by data source. After all that, date and time can be considered for better organization, filtering through searches, security, and automation. Granularity level of the date and time depends on the application. So looking at our options here, first start by ruling out BNC since the parent directory starts with some sort of date. And we can rule out A as well, because although it starts with subject area and data source, date comes before month and year. We always want to start with whatever is going to change less. So a good example of that is option D, where we have subject area and data source, and then we have year, month, and day. Question 7. You need to output files from Azure Data Factory. which file format should you use for each type of output. And the two types of outputs that we're looking for is columnar format and JSON with a timestamp. In one of the questions from before, we discussed some data formats. So that included Avro and Parquet from this list in this question. So what are gzip and text? So gzip and text, they're both file formats that we can ingest data in. So since here we're looking for file format that we can use to output the data, those are not relevant here. But just out of interest, going through them quickly, gzip compressed binary format, and text is a human readable format. And going over Avro and Parquet quickly as well, if you remember, Avro is a row-based format and Parquet is a column-based format. And if you remember as well, Avro is compatible with timestamp data. So columnar format, the correct answer is C, Parquet, and JSON with a timestamp, the correct answer is A, Avro. Question 8. You use Azure Data Factory to prepare data to be queried by Azure Synapse Analytics serverless SQL pools. Files are initially ingested into an Azure Data Lake storage Gen 2 account as 10 small JSON files. Each file contains the same data attributes and data from a subsidiary of your company. You need to move the files to a different folder and transform the data to meet the following requirements. Provide the fastest possible query times, automatically infer the schema from the underlying files. How should you configure the data factory copy activity? So there are two parts to this question. First, we need to answer the question for copy behavior, and after that we need to answer the question for sync file type. So reading the question here, it doesn't seem like there's any hierarchy that we will be looking at. So copy behavior, we can ignore the two hierarchy options and we can go straight with B, merge files. And in terms of the sync file type, we're dealing with JSON here, and it seems like we will be looking at columnar based format. So as we discussed a couple of times before, the file format we want to be looking at is Parquet. Question 9. You have a data model that you plan to implement in a data warehouse in Azure Synapse Analytics as shown in the following exhibit. All the dimension tables will be less than 2 GB after compression, and the fact table will be approximately 6 TB. The dimension tables will be relatively static with very few data inserts and updates. Which type of table should you use for each table? And we're given 1 fact table and 3 dimension tables. So this question is to do with the table distribution. So when a table is distributed, even though it appears as a single table, the rows are actually spread onto 60 different distributions. And how do we separate out those rows? Well, there are 2 algorithms that we consider, and depending on which algorithm is used, one of them is called hash distribution and the other one is called round robin distribution. And we'll come back to replicated to explain after these two, but these two are pretty good to compare first. I'm not going to go into detail with what each of them do, but for this certificate what you have to know is that hash distribution is especially good for improving the query performance for large fact tables, and round robin distribution is good for improving loading speed. Actually, round robin is the default distribution. If you don't specify any distribution, then you'll go with round robin. That's because it's considered as a good starting point if there's no obvious distribution column and things like that. When a table is replicated, that means that there is one copy of the table in each compute node. The advantage of doing that is it removes the need to transfer data among compute nodes before joining and aggregating, so the whole process gets a lot faster. And of course, since the table is copied multiple times, the trade-off is the storing size. So the replicated tables approach really work better for smaller tables. The rule of thumb is that the table should be less than 2 GB. So applying the ideas that we discussed here, For the dimension tables, they're less than 2 gigabyte. So the replicated tables would be ideal for those dimension tables. And for the fact table, it's a 6 terabyte, a big table. So we can go with the hash distribution to optimize the performance. Question 10. You have an Azure Data Lake Storage Gen 2 container. Data is ingested into the container and then transformed by data ingestion application. The data is not modified after that. Users can read files in the container but cannot modify the files. You need to design a data archiving solution that meets the following requirements. New data is accessed frequently and must be available as quickly as possible. Data that is older than 5 years is accessed infrequently but must be available within 1 second when requested. Data that is older than 7 years is not accessed. After 7 years, the data must be persisted at the lowest cost possible. Costs must be minimized while maintaining the required availability. How should you manage the data? And we need to look for the solutions for the 5-year-old data and 7-year-old data. So the question deals with blob storage tiers. So there are 3 tiers, right? So there is hot, cool, and archive. And they're pretty easy to understand and pretty intuitive as well. Hot is, it costs a lot to store, but cheap to access it and play around with it. And the other end of the extreme is archive. It's cheap as to store, but pretty expensive if you wanted to access it and play around with it. And cool is somewhere in between those two. Not that expensive to store, not that cheap to play around with it and access it. Looking at our question here, so for 5-year-old data, it is infrequent but it is accessed, but must be available within 1 second when requested. So for this one, since our access is not frequent, we don't want to go with hot. When we want it, it has to come quick. We don't want to go with archive as well. Because if we go with archive, there's this thing called rehydration, which takes quite a long time. It's basically like, okay, we haven't used this data for ages, so we need to do this process called rehydration before we can use it. So it's gonna take more than 1 second for sure. So for 5-year-old data, we move to cool storage. For 7-year-old data, which is not accessed at all, and we want to keep it at the lowest cost possible, we move the data to archive storage. Question 11. You need to create a partition table in an Azure Synapse Analytics dedicated SQL pool. How should you complete the transact SQL statement? On the screen, you can see the syntax for creating a table on Azure Synapse Analytics. As highlighted, the blanks should be distribution and partition respectively. The giveaway for the first blank being distribution is the hash function following the equal sign. Question 12. You have an enterprise-wide Azure Data Lake Storage Gen 2 account. The data lake is accessible only through an Azure virtual network named VNet1. You are building a SQL pool in Azure Synapse that will use data from the data lake. Your company has a sales team. All the members of the sales team are in an Azure Active Directory group named Sales. POSIX controls are used to assign the sales group access to the files in the data lake. You plan to load the data to the SQL pool every hour. You need to ensure that the SQL pool can load the sales data from the data lake. Which 3 actions should you perform? Every time we talk about accessing data in data lake through virtual network, we immediately think of managed identity. We're supposed to choose 3 options out of all the options here. Just glancing through it, there are only 3 options that has the managed identity in them. But looking at them a bit close, first what you do is you create a managed identity and add the managed identity to the sales group and use the managed identity as the credentials for the data load process. So the correct answers are F, A, and B in that order. Question 13. You have an Azure Synapse Analytics dedicated SQL pool that contains the users shown in the following table. It shows the user 1 with server admin role and user 2 with DB date reader role. User 1 executes a query on the database and the query returns the results shown in the following exhibit. User 1 is the only user who has access to the unmasked data. And the questions are, when user 2 queries the yearly income column, the values returned will be, and when user 1 queries the birth date column, the values returned will be, and there are two blanks following those two questions. So this question is to do with dynamic data masking. So dynamic data masking limits sensitive data exposure to unprivileged users by masking it. An example of that would be if I was working in a bank, for example, and I'm a cashier, so I don't have access to all the privileges, and maybe a customer comes and I need to look up their information, and I look up their name. Maybe I'll have access to the name, but maybe not their phone number. The phone number column will be masked, their email will be masked, as well as like maybe their bank balance will be masked for me as well. But for someone like maybe their finance advisor, they will have access to all of it. So looking at this question here, we can see that the columns that have been queried are all masked. So there are certain policy to dynamic data masking. So for example, if the masked column is a string column, when we query it, it will appear as 1x or multiple x's. If the masked column was a numeric column, then it will appear as just 0. So looking at the first part of the question here, when user 2, who by the way doesn't have the privilege, when user 2 queries the yearly income column, the values returned will be 0 in this case because the yearly income column is a numeric column. And when user 1 queries the birth date column, the values returned will be the values stored in the database, since user 1 is a server admin, so they have the data access privilege. Question 14. You have an enterprise data warehouse in Azure Synapse Analytics. Using Polybase, you create an external table named ext items to query Parquet files stored in Azure Data Lake Storage Gen 2 without importing the data to the data warehouse. The external table has 3 columns. You discover that the Parquet files have a 4th column named item ID. Which command should you run to add the item ID column to the external table? So for external tables, only create and drop commands are allowed. Just using that filter, the correct answer is either A or C. And since we're dealing with an external table here, we can get rid of option C, which looks at external file format. Just going through it here, we can see that the table is first dropped and then is created again with the item ID column added. Question 15. You have 2 Azure storage accounts named Storage 1 and Storage 2. Each account holds 1 container and has the hierarchical namespace enabled. The system has files that contain data stored in Apache Parquet format. You need to copy folders and files from Storage 1 to Storage 2 by using Data Factory copy activity. The solution must meet the following requirements. No transformations must be performed. The original folder structure must be retained. Minimize time required to perform the copy activity. So how should you configure the copy activity? And there are 2 parts to this question. First part being, what's the best source dataset type? And the second part being, what should the copy activity copy behavior be? So let's have a look at the first part of the question here. What should the source dataset type be? The key part of the question to notice to answer this question is that no transformations must be performed. So when using the binary dataset type, the service does not parse files but treat it as is. And hence the correct answer for that is A, binary. So the second part of the question is quite straightforward here. But before answering that, maybe we'll quickly go through what each of the options mean. So flatten hierarchy, as the name suggests, it collapses all the files in the subfolders to the first level of the target folder. So all files from the source folder, even in the subfolders, get copied into the first level of the target folder. So we can see that it's flattening because it's collapsing all the hierarchy structure and then just putting it in one place. Whereas the preserve hierarchy, as the name suggests, preserves the hierarchical file directory structure. And merge files, what it does is it merges all the files from the source folder to one file in the target folder. And in the question, the second bullet point says the original folder structure must be retained. So the correct answer here is C, preserve hierarchy. Question 16. You have an Azure Data Lake Storage Gen 2 container that contains 100 terabytes of data. You need to ensure that the data in the container is available for read workloads in a secondary region if an outage occurs in the primary region. The solution must minimize costs. Which type of data redundancy should you use? This question is to do with data redundancy. So largely there are two types of data redundancy. Data redundancy in the primary region and data redundancy in the secondary region. Let's have a look at each of them first. So all the data in the primary region is copied 3 times. And there are 2 storage options to determine how the copies are made. The first one being locally redundant storage, or more commonly known as LRS, and the second one being zone redundant storage, or more commonly known as ZRS. So using the LRS, the copies are made in a single physical data center, and with ZRS, the copies are made in 3 different availability zones. So moving on to the data redundancy in the secondary region, there are also largely 2 options here. The first one being geo-redundant storage, or more commonly known as GRS, and then the geo-zone redundant storage, or more commonly known as GZRS. For both of these options, what's happening is there are copies made in one region, and that set of copies copied into a secondary region that's far away from the primary region. How that copies are made in the primary region determines which storage option you are using. So with the GRS, the copies are made using the LRS, and that set of copy is copied in the secondary region. With the GZRS, you may guess already that in the primary region, the copies are made using the ZRS, and that set of copies copied into a secondary region. And so the remaining questions are then, what are these RA, GRS, and RA, GZRS? Well, with the GRS and GZRS, by default, you cannot access those files unless the data copy in the primary region is all inaccessible. So in order for us to access our data copy in the secondary region, even without the primary region failing, what we can do is we can enable the read access. You can think of RA, GRS, and RA, GZRS as the fancier versions of GRS and GZRS. So looking at the question here, we need to ensure that the data in the container is available for read workloads in a secondary region if an outage occurs in the primary region. So we can get rid of the storage options that's to do with within the primary region. So that's C and D. We can get rid of them. And since we need to minimize costs, we don't want to go with the RA-GRS, so the correct answer here is A. You plan to implement an Azure Data Lake Gen 2 storage account. You need to ensure that the data lake will remain available if a data center fails in the primary Azure region. The solution must minimize costs. Which type of replication should you use for the storage account? This question is also to do with the data redundancy. We can use what we learned in the last question in this question as well. So in this question says, we need to ensure that the data lake will remain available if a data center fails in the primary Azure region. So we're looking at just our primary region here. And reading on a bit further, we know that the solution must minimize costs. So we'll get rid of the storage options that's to do with the secondary region. So we'll get rid of GRS and GZRS. So what's remaining is LRS and ZRS. If we were to go with the LRS option, because all the data copies are made in a single data center, if the data center fails, then all our data will be inaccessible. Our storage options that satisfy the question is D, zone redundant storage. Question 18. You have a SQL pool in Azure Synapse. You plan to load the data from Azure Blob storage to a staging table. Approximately 1 million rows of data will be loaded daily. The table will be truncated before each daily load. You need to create the staging table. The solution must minimize how long it takes to load the data to the staging table. How should you configure the table? This question is about the best practice to load data from Azure Blob storage to a staging table. When we load a data to a staging table, the best practice is to use round-robin distribution. And for indexing, the best practice is to use heap. So the answer is the first two parts of the question here. And for the third part, asks about partitioning. And if we read the question again here, it says here that the table will be truncated before each daily load. So this is a true staging table, and therefore partitioning won't really be necessary for this. So the answers for this question are C round robin, C heap, and B none. Question 19. You are designing a fact table named fact purchase in an Azure Synapse Analytics dedicated SQL pool. The table contains purchases from suppliers for a retail store. Fact purchase will contain the following columns. Fact purchase will have 1 million rows of data added daily and will contain 3 years of data. Transact SQL queries similar to the following query will be executed daily, which table distribution will minimize query times. We've discussed before that the distribution that optimizes the query performance is the hash distribution. So that narrows down our options to either B or D. And the only difference between B and D is which column the distribution is applied on. So there are 3 recommendations from Azure to decide which column to apply the distribution on. So the first recommendation is that there should be many unique values in the column. Second, there should be none or almost none nulls. Third, it shouldn't be a date column. So looking at our options here, we can rule out D because the column is order finalized. There will only be 2 unique values there, so we can rule that out. So the correct answer here is B, hash distributed on purchase key. Question 20. From a website analytics system, you received data extracts about user interactions such as downloads, link clicks, form submissions, and video plays. The data contains the following columns. You need to design a star schema to support analytical queries of the data. The star schema will contain 4 tables, including a date dimension. To which table should you add each column? This question asks about the star schema. So what is the star schema? The star schema is a data modeling approach that involves fact tables and dimension tables. Dimension tables are the tables that tell us about business entities, and fact tables are observations that's to do with these business entities. Going through this question will be a perfect introduction to the star schema here. So looking at the event category column, the sample value of that is videos. So it's a business entity rather than an observation. So it will be one of the dimension tables, and it makes sense to use the dim event table. And looking at the channel grouping, the sample value for that is social. Again, it's more of a business entity rather than an observation. So we'll put into a dimension table as well, dim channel. And total events, sample value being 150, we can see that it's more of an observational value. So we put in an fact table. The only option for that is fact events. Question 21. You have an Azure storage account that contains 100 gigabytes of files. The files contain rows of text and numerical values. 75% of rows contain description data that has an average length of 1.1 megabyte. You plan to copy the data from the storage account to an enterprise data warehouse in an Azure Synapse Analytics. You need to prepare the files to ensure that the data copies quickly. The solution? You convert the files to compressed delimited text files. Does this meet the goal? This question is to do with the best practice for loading data in a serverless SQL pool in Azure Synapse Analytics. So each file format has different advantages, and for the fastest loading times, it is recommended to use the compressed delimited text files. So the answer to this is yes. Question 22 is exactly the same as question 21, except the solution is you copy the files to a table that has a column store index. Does this meet the goal? This question is again asking about the best practice to load the data in Azure Synapse Analytics. As we discussed a couple of times before, To optimize the loading speed, we don't use the column store index, we use heap. Question 23 is also same as the last two questions, except the solution is different. The solution in this case is you modify the files to ensure that each row is more than 1 megabyte. Does this meet the goal? To optimize the loading speed, it doesn't help to make the size of the rows bigger. So the answer to this is no. Question 24. You build a data warehouse in an Azure Synapse Analytics dedicated SQL pool. Analysts write a complex select query that contains multiple join and case statements to transform data for use in inventory reports. The inventory reports will use the data and additional where parameters depending on the report. The reports will be produced once daily. You need to implement the solution to make the dataset available for the reports. The solution must minimize query times. What should you implement? To optimize the query performance in a dedicated SQL pool, the easiest way to do so is by using a materialized view. Using a materialized view, you can really optimize the query quite easily since you don't have to change any syntax. So the correct answer here is B. Question 25. You have an Azure Synapse Analytics workspace named WS1 that contains an Apache Spark pool named Pool1. You plan to create a database named DB1 in Pool1. You need to ensure that when tables are created in DB1, the tables are available automatically as external tables to the built-in serverless SQL pool. Which two formats can you use for the tables in DB1? The question is about synchronizing the Apache Spark pool with table definitions of serverless SQL pool in Azure Synapse Analytics. The synchronization can be achieved by using the CSV and the Parquet format. So the correct answers here are A and D. Thank you for watching the video, guys. We got this together, guys. Love ya.